Kia ora koutou. This video is for class on Thursday, June the 8th, and I'm making it because I'm really sick of being stuck at home with COVID and not being able to teach you properly. So I decided that I would try for once to do a video where you can actually see me in it, which I really hate, but I'm going to try and make it as much as if we were in class together as possible. So today what I want to get onto is why we're calling this standard inference, and the crucial part of what we're doing, which is that we're starting off with a sample and trying to say something about the population. So I'm going to try and work through a PowerPoint fairly quickly here, and then your main task today is to go and do some bootstrapping using a fabulous thing that Jake Wills has built on his website. Okay, so the first challenge is to get the PowerPoint to work. Let's see. Right, here we go. Okay, hopefully so far this week, when you've worked with Liz Sneddon's materials, you've understood that we have to start off by asking a question about our population, right? So the question is looking at the difference in the population medians, and in this case I'm looking at rugby players, and I'm interested in knowing the difference in the median weights between the forwards and the backs. And we've done a bit of work on how to word that exactly, but that's not going to be my focus today. But what we're stuck with is a sample, right? But we're not really just interested in the sample. We want to be able to say something about the population. But first up, we do a really good job of analysing the sample. We look at the centre and we look at the shape and we look at how spread out it is and so on. And we write lots of interesting stuff about the patterns that we can see in our sample. But the whole way through that analysis, we have to be careful to say, well, what we've got here is a sample, and we can't be sure that what we're seeing in the sample is going to stick back in the population. Right, so just moving on quickly to the next slide, I think. Okay. What we're interested in, though, is the difference in the population medians. So I want you to have this really cheesy, bad picture in your head, that what we're trying to do is to use bootstrapping to bridge us from getting from the sample, which I've called here sample island, over to population island, right? So you can tell that my COVID-fogged brain, I had to have some fun with stupid pictures of things from the internet. So we've got the bootstrapping bridge that will get us from one island to the happier island. And the happy island is population island. So what we have to do to pass this achievement standard is to do a bootstrapping confidence interval, and then we have to interpret that confidence interval, and we have to use it to make a call about the difference in the medians. And if we don't do that, we fail the achievement standard, right? We are stuck on sample island forever. Or if we do the bootstrapping badly, then I guess we fall the ocean, which would also be bad. Okay, I bet most of you have stopped watching the video in horror by now. Let's see. Okay, so moving on from population island, how are we going to do this? Well, we're going to use bootstrapping. Never have me in the picture because it just goes better. Right, okay, on to the next slide. So we're going to do this using NZGrapher, but today we're going to go and do it really slowly. Usually when we do it, we're going to hit one button and NZGrapher will do 1,000 resamples from my samples, and I'll explain what that means in a minute. We have to start getting confident with the language that we're using here, and so here's a little table to give you where the words fit in. So what we're interested in is a population parameter, which is the population median of the forward weights and the population median weight for the backs. And we want to know the difference in those two population medians. So that's what we mean by parameter. There's a fixed value of the population median for each of those populations, and we're looking for it, but we know that we're never going to find it. Right, so what we've got instead is we've got a sample, and the sample gives me an estimate of that population median. We're going to go over and over this because this is pretty fundamental, but that's about all you need to know for today. Okay, so why do we want to do this? Well, what we would like to be able to do, we can't measure the whole population. But one thing we might in theory be able to do is to get loads more samples. And if we could do that, then we could figure out the median of each one of them, and we could maybe use that to get an idea of the population median. And that's basically what bootstrapping does, except there's a catch, right? So this is the big idea, that a different sample will give us a different median. And we call that sampling error, and we've seen that when we did our stat reports topic. And the variability of sample estimates is something that we just can't eliminate, but we have to find a way to measure it or quantify it. Okay, so that slide is just an old slide that I've chucked in there. That's a summary of what we're doing in this achievement standard, right? So first up, we've got the question then we analyze the samples, and then we do the bootstrapping bridge, right? So we're not just going to use our sample because it's just a sample. So we're going to build a confidence interval for the difference in the medians back in the population. We know from stat reports what a confidence interval is. It's a plausible range of values where we can be pretty sure that the difference in the medians actually lies. Okay, so bootstrapping is always going to give us a better estimate of where the population median difference lies than if I just use my sample. So we must use it. Okay, so when we do bootstrapping, we're going to do 1,000 resamples from our one sample. And we don't care if the sample sizes are a bit different. I'm going to show you what this looks like in a minute. So this link here hopefully is going to work. This takes us over to a page on Jake for Maths. And hopefully you can see that up there. This is what he calls a manual bootstrap activity. And what you can see here is that in the blue, we've got the weights of the backs in his original sample. And then we've got the weights of the forwards. The first thing that I want you to notice is that the numbers for those two samples are not equal. And that really doesn't matter, right? It's fine that they are different sample sizes. I think every year a couple of people tell me how terrible it is that they haven't got exactly equal samples. As long as both samples are big enough, then it's fine. So what we're going to do now is we're going to get a sample with the same number in it by resampling from that original sample. And when we resample, we're going to put our number back so that we're resampling with replacement. Right, so there's my very first draw from my resample. This is my first resample. Remember that I'm going to do 1,000 of them. Right, so we get 117 kilograms and it's from a forward. Now we do it again. Oh, we got 117 again, but it's a different person, right? Let's do it again. And we've got another forward. Okay, and that forward weighed 98 kilograms. Now this time we've got a back who weighed 85 kilograms. Now we've got a back who weighed 93. So you can see that I might end up sampling the same rugby player twice, right? And there's nothing wrong with that. In fact, that's how bootstrapping works, is that we're resampling with replacement. So we do this over and over. And now I'm going to go fill all just to do it quickly. And when we do Integrapher, it's going to do this 1,000 times over so fast, like in the blink of an eye, it's going to do 1,000. Now, what we've got from that is that we have got a new resample, and we're going to work out the forwards median and the backs median. Okay, and you can see that the difference for that resample was 23 kilograms, and it's put a very nice little dot down here. Okay, now we're going to do it again. Right, first guy, 84 kilograms, and he's a back. Now we've got another back, 85 kilograms, and so on. Right, so we do it again. And this time, let's see what we get. Right, this time the numbers are slightly different, right? The forwards median is 112 kilograms, and the backs median is 92 kilograms. Remember, in the first one, they were 113 and 90. So we've got two differences now here. We've got the first one, which was, let me see if I can do maths today, maybe not, right? That's the new one there, and that's the first one. Okay, we'll do it again. I'm not going to do this 1,000 times because I'm going to run out of recording time. At this point, there is a caramel chocolate thing for anyone who's still watching. First person to email me and tell me they got to this point in the video will get the chocolate when I'm back at school. Okay, calculate the difference. What do we got? Okay, there's our third one, 17. So what we're looking at is we're going to do this 1,000 times, and we're going to see out of the 1,000, where are the middle 950 of those numbers. So to put us all out of our misery, I'm going to do fast fill now. Oh, no, I actually do have to do this over and over again. Okay. Right, I'm going to stop here because what I want you to do is that your job in today's lesson is to go in and use this. And I want you to build up this bootstrapping activity until you've done this, I don't know, let's do it. If you can each do it 100 times. And then I want you to try and estimate where the middle 95 of those 100 are. I want you to take a screenshot of that, and then you're going to email me in your work. Okay, I think that's about all for now. We're going to spend quite a lot of time finessing what we've done here, but this big idea is that we can resample with replacement lots and lots of times to artificially build up a picture of the sampling variation that we've got. Thanks for watching, and I hope everything goes well today. If anyone there hasn't got their laptop, then you can do some work in the Walker workbook on this instead.